Our last talk is about a topic near and dear to all of our information security hearts, point of sale systems. Gee, I wonder why it's near and dear to our hearts. Here to talk about it today is a gentleman, Nir Valtman.
Hi, pleasure to be here today.
Wait, I'm sorry. Are you a new speaker?
Yeah.
Oh, excellent. I just didn't want him to get too much into it.
Okay, guys.
What do new speakers do?
Yes.
It will be fun.
It's a requirement. No poison testers needed. I'll take the hit. Thanks. Sir?
Give me more. I'm
Oh, you
fine.
want some more?
No, I'm fine.
Wait. I've been doing this all day. Love for the new speaker.
Cheers. I'm Russian, by the way, so it doesn't really matter.
That's all we have time for. Thanks everybody for coming. DEF CON is canceled.
Good man.
Do you have other bottles?
No, we're not leaving the bottle.
Okay. So I'm Nir, and I'm going to speak today about my journey to protect point of sales. I do a short introduction, and then I'll get into details. So first of all, that's the thing when I say to other people what I do. Well, obviously I'm not the Batman, the cashier. Actually, I'm working as an enterprise security architect. I solve a lot of problems in a retail line of business, but actually I do it only for these guys. I had a few researchers about this, and released a few of open source tools. But I'm here today to speak about the last year research that I've done and a lot of the result of meeting with a lot of startup companies and enterprises in order to protect point of sales. So before we begin, I just want to show you the view of why point of sales are so targeted. So today when we want to buy credit cards, I just took something through Tor, and I saw that it's pretty easy to find credit cards and get them with pretty low prices. But when we want to get a little bit more information, we can get full dumps. Full dumps, guys, this is something that is stolen from point of sales. If we differ it from other scenarios where like e-commerce or m-commerce websites, then there you just store PANs, which is the credit card numbers and the expiration date. So here we have a little bit more information, and if we compare it a little bit about what should be attacked more, we can see that although e-commerce is exposed to the internet and it's pretty easy to try to attack this vector, point of sales have the same things, but also the full dumps. The full dumps, by the way, it's track 1, 2 data, and sometimes it can also contain the PIN number. So before we get into the security stuff, I just want to talk about what is point of sale, because someone would just think about this thing, which is right. This is a point of sale, but this is only for the retail stores. The simple assumptions about point of sales in the retail store is that it can be stolen, or at least it can be tampered, as these ones, fuel pumps. Fuel pumps, well, they're public. It's pretty easy to tamper them as we do to ATMs. You can just put skimming devices there. That's fine, that will work. But the next point of sale is kind of a new point of sale. It's mobile POS or MPOS. The idea of MPOS is to shorten the queues on the retail stores, and that means just for queue busting. But the fact is that since it has no wires, it has a card reader, can be replaced pretty easily. And also, I don't know if you see the right bottom corner, you see kind of a scanner. It's a Bluetooth scanner, and it contains all the risks with connecting Bluetooth devices to the point of sale. But in fact, we're attacking point of sales. We shouldn't attack point of sales. This picture, by the way, means that there is no spoon, because point of sale is not exactly the thing that should be attacked. The thing that should be attacked is the payment application. Payment application, this is something that can be inserted as part of another DLL of the POS, or it can be an external executable, and this is the thing that should be attacked. Just to give you some overview about how it works on retail stores. So generally we have the store and we have the payment processor data center. Obviously we have the store, we have headquarters. I just tried to simplify that a little bit. So if we'll go to the store, we'll see that any POS has its own application. The POS manages identities like cashiers, it has loyalty systems, but it doesn't manage any credit card data. The only thing that it can manage is authorization code that we get back from the processor. We also have the payment client, which is the one that's responsible for processing the credit card. And all of this data is somehow stored in a database or a file system, and obviously in the RAM at a certain point of time. The PA client communicates with a point of interaction or pin pad or magnetic stripe reader, and then it passes the credit card numbers to a PI server. Obviously there may be point of sale server in other places or headquarters, but again I just try to simplify that. So we have a store server. Probably this store server is going out to the processor. This payment server contains credit cards, again at least at specific point of time, and then it goes to the processing. So let's just understand where are our credit cards, because when we speak about the risks and explaining how to exploit everything, we just need to understand where to exploit it. So if we look at the data at rest, probably we'll see it on files or databases, and it's pretty weird because why do we have to store credit cards in a database? So this is pretty simple. Let's say that the store is disconnected from the center or from the processor. So what? So the store can't sell? It can sell. Okay? How it sells? It just stores the credit card somewhere. It can be in the database, it can be in the file system. So then we have the data in transit. And here we just need to understand that the data in transit is not only something that we can or need to see through the Wireshark. Sometimes the data in transit is from the pin pad to the PA client. It can be done through RS-233 and can be done through USB. So that's the options. As for the memory, which is the most common way of attacks on point of sales, we have it in the RAM. Just to connect it to the way we work today and we see retailers, let's say that the retailers don't have only point of sales in the stores, they also have an e-commerce. And if they have e-commerce, probably they have a PA server, payment application server. So if they have a payment application server, they probably have a presentation layer, they have m-commerce, e-commerce, it doesn't matter, but somewhere there are credit cards as well. So if we look at data at rest, probably it will be in the same place. As for the data at transit, again it's over the wire here. But then we have the data in memory, and we have it also in the presentation server, which is pretty easy to try to look for data there, if it's, by the way, exploitable. But the thing that we never thought about storing credit cards, or at least looking for credit cards there, is the mobile app. So the mobile app also contains credit cards. So there are ways to somehow remove these credit cards from all these places. And this can be done by just storing all the keys in a specific server called token server. That's a concept. That means that this is a pretty simple server. It contains a table, credit card, a token. And then when we pay, we just pay by token. We don't pay by credit cards. And then it means that the presentation server don't need to have actually credit cards there, and the application server neither. On the other hand, when we have a wallet, somehow we need to register our credit card there. So when we register the credit card, it is in the memory. So we don't have exactly a solution for everything, but at least we solved here for the PA server, no problem here. So let's just understand a few assumptions about what the retailers think when they deploy their point of sales. Okay, so the first thing, yeah, no one cares, really. PCI, well, it's a marketing thing. It's not a security thing. Okay, so the next thing is the fact that retailers actually deploy the point of sales on embedded devices. Well, it's Windows embedded. So does it mean that Windows embedded is secure?
It's not as bad as regular Windows 7.
Yeah, it's not as bad as regular Windows 7, but yet it doesn't mean that it's secure enough. And then part of them tell that, well, we have patches. We all know that no one cares about patches. Yeah. And you know why? Yeah. Do you know why the retailers are not vulnerable to the Heartbleed? That's pretty easy. Because most of them don't have even SSL. Yeah. So another assumption is that they're not connected to the internet. Well, actually, they're not connected directly to the internet. They have the store, they have the headquarters, but somehow they'll need to go to the internet. How they have patches? Okay. So all of them connected to the internet, this is just a fact. Another fact is that retailers believe that the cashier can be a hacker. So the cashier can be a hacker, but is his USB stick can be a hacker? Probably. And it happens. The next thing is something pretty odd. I just asked one of the retailers, hey guys, do you log? How do you know that you don't have fraud on the pauses? And they told me, well, we have cameras and we see if the cashier just gets the money from it. So we don't have fraud because we have physical security. No one cares. But again, these are only assumptions, but in fact there are few Achilles tendons in the retail environments. This is the first one. Whoops. This is the one. The rats. The fact is that on most retailers they have a lot of sites. And it's pretty hard to put IT guy on each site, let's say more than 1K sites. And then they just install VNC. Okay, so VNC is also vulnerable. And again, this is a fact that most of the retailers can't handle with. Another thing is who can access the POS? Well, the POS is a Windows machine. Sometimes it's in a domain. So that means that any user from the domain can log into these machines. Yeah, actually, they are. Another fact is that no one really knows how to harden these systems. So the point of sales run with local admin access control. So you don't have to manage permissions. I know that PCI requires managing permissions, but I'm admin. Who cares? So let's talk about the threats because, well, there are many threats on the point of sales, and we need to solve at least part of them. So the first threat, which is the low-hanging fruit, is the permissions on the point of sale. So as I said, if we have admin, yeah, that's good. We already found it. But yet, if we don't have the admin access and we have a regular user, still we have specific permissions to the application. So for instance, if we have a pin pad, probably we'll need to manage the permissions to managing the drivers. These ones, yeah. Okay. Another thing is permissions to the process. Do you know that if I run the process as a logged in user, it doesn't matter which process do I run, I can read it. So if I run the point of sale with a logged in user, I don't even need to exploit the operating system. I just need to run a memory scraper. And it's pretty easy because I have the permission. So again, there are file system access. Sometimes the point of sales write logs, and when they write logs and we can change them, we can probably do a fraud or sometimes be exposed to credit card numbers in the logs. That's a bug, by the way. Every retailer that you'll see that there, it's a bug. It's not by design. But somehow all of them designed this bug. So another fact is that in many point of sales you'll have the database on the point of sale because sometimes you'll need to work in offline modes. So you have the database on the point of sale. So hey guys, you don't need to hack the point of sale. You can just take the MDF file. That's fine. Another threat is something pretty common on browsers. Well, on browsers, when you go to a URL with HTTPS and then the certificate is not correct, probably you'll get a warning, right? But point of sale is not a browser. Point of sale can do whatever it wants. So point of sale can ignore HTTPS errors, obviously if they have HTTPS. So I can actually put any certificate that I want in the middle because no one cares if it's trusted, and then just open its SSL connection and it will work. As for the business perspective for paying through the point of sale or the payment application, we actually have pretty long flow until we get the authorization from the issuer. So we have the point of interaction, which is the pin pad that passes the data to the PA application. Then it routes the data through a gateway and then a processor, and then obviously it goes to the issuer. But the main thing that we must understand here that this spot is pretty protected, and that means that it's pretty hard to exploit it. I'm not saying it's impossible, I'm just saying that this is not the point of sale scope. So the left side is the side that we need to exploit, but hey, I'm just stealing data from the memory, and that means that it can consume some time, and sometimes even when I try to do this memory scraping, well, it consumes, I can say a lot, but it consumes resources from the point of sale, and just to explain you how weak is the point of sale, it can be Pentium 4. It's pretty old, right? So if it's Pentium 4, probably you'll see a memory scraper, you'll see the performance goes up. And it will be much difficulter to get the data because we just need to wait a lot of time until we get all the credit cards that we want. On the other hand, there is a settlement flow. The settlement flow just stores the credit card somewhere. It can be on the POS, it can be on the store server, it can be on the headquarters. It really depends on implementation. So again, we have something specific that is protected, but yet the credit card's stored somewhere, and that means that they're not in the memory, they're on a disk. Well, that's easy. I just need to go to the disk and get the file. That's fast, by the way. The memory scraping, this is something that, as I said, is pretty common on point of sales. And I just want to do a short demo to explain you how it works. Okay, so I have here a Windows machine, and I have here kind of application, pretty simple application that a few of my students wrote, and I was supervising of it. And this memory scraping does pretty simple thing. Just goes to the process that we choose and gets the memory from it and translate it to a string, and then try to find a credit card based on a regular expression. So let's say that this is our pause. Pretty nice pause, right? I'll just set the pen for a moment there. You know what? Without the pen. Just do it like this. So now we'll go to the process. And we'll choose credit cards. When you see that I just started the scan, nothing's there. But when I set the credit card, whew, it works. So when I set the credit card, I can see that in a moment I get it. Memory scrapers, they just don't work in one iteration. We just need to open a few threads and then refresh them every 5, 10, 30 seconds, depends how much credit cards do we want to get. So this is pretty simple to get the credit card, but hey, I'm running as admin here. Well, this runs as admin. So let me just close it and do it without the admin. So I'm again going to the demo, and just to explain who am I, here we have this is a user named Foo, it's not admin, and now I can run again the point of sale, and let's just try to get something from this spot. So I just injected DLL to this point of sale. I just used the framework injection. It's an open source framework that allows DLL injections. I just added something to the point of sale, tried to scrape the memory from it, and then I get the log. Obviously I can't see, whoops, didn't remove the old one. Need to close the point of sale. Great. So now I have the memory scraping point of sale, and I just inject the DLL in there. Probably I won't see any credit cards there because there are no credit cards set here yet. Nothing. And again, if I'll set the pan, I'll delete this one. Let's do it again. We have the credit card. So that's the idea of injecting DLLs into the pause. We can just get to the process and do whatever we want, even if we don't have the admin access to the process. We'll do the questions later, okay? So this is the memory scraping, pretty easy thing. Didn't take so long to do it because you'll find read process memory documented, well documented in the internet. So there are other things that can be done on the pause. We can actually steal credentials. It can be cashier credentials or user credentials, because sometimes on retail stores you just register to the store through e-commerce, and then it's stored somewhere, and when you just buy something in the retail store, you have a loyalty card, and sometimes this is even connected to the user and password. So if you can just scrape something else from the memory, you'd probably be able to get the login credentials and then use them obviously on other websites. Another thing that you'd probably be able to do is to get the PII data on the point of sales, because point of sales store PII data, because we have, well, your address, telephone numbers, email sometimes, and this is a data that costs a lot of money for the ones that steal it. But another thing, another fact on point of sales is that no one really deploys a thin point of sale. That means that no one really deploys only the presentation layer. All of them deploy a thick point of sale. And that's the picture because I didn't find a thick point of sale. So the fact is that all the business logic and the database, everything installed on the point of sale. There are retailers that are brave enough to duplicate their network lines, and then if one network line just fails, they have the other one, but that's pretty expensive, so just prefer to run it. But when we steal the credit cards, we have actually two scenarios. Probably you heard about one of them. The most common way to steal credit cards is using an online approach. The online approach means that I'll find a way to get from the POS to the internet. Somehow I'll find this way. It can be done through a proxy, it can be done through another server, FTP servers, etc. So somehow it will get to a CNC server in the end. But as I said, not all retailers actually have access or direct access to the internet, and it's not really easy to do it on all times. So if I'm a cleaner on a retail store, I can just take a USB stick, put it somewhere on the PA server, and then just run, again, the memory scraping. But then the exfiltration of the data will be done to a specific ID of the USB key. Then when I connect it to the point of sale, then I'll get the credit cards back to this storage. So these are mainly the two approaches. So I checked a few solutions of how really to protect the point of sale. So I thought about, well, before going to solutions and trying to purchase software to protect point of sale, maybe we can code something. So I thought, okay, maybe I can use, this is by the way something specific for .NET, but probably you'll see it for any other managed code. I just thought maybe we can use another way to encrypt the credit card in the memory. So there is a class in .NET that's called secure string class. This is a managed class of string. Yeah, this means that if it's managed, maybe we can bypass it. And again, we have a demo. Okay, so we have another secure string point of sale. That's pretty cool. When I send a pen, nothing to show because it can show me the string. It's a secure string. And as I said, it's a managed code, guys. So if it's managed, we can just decrypt it. It's done easily by marshalling the secure string using .NET. No need for specific knowledge here. Just go to the internet and get this 5 lines of code. And again, if we'll do the memory scraping here, and obviously we can do the memory scraping and calling this function to decrypt the credit card. Probably we'll see here the credit card. Yeah, come on. So that's the idea of secure string, and I figured out that coding won't work here, and obviously I won't be able to change all the point of sales that I know. So I thought about other solutions, and then I investigated. Maybe firewall will help here. Well, it doesn't matter which firewall next generation will it be, because, well, most of the point of sales today work with HTTP. So if they work with HTTP, it doesn't matter which next generation firewall you'll have there. And neither the antivirus malware and all the other curses that we have, it won't work. Because, you know what? It's Pentium 4. How will you run a whole endpoint security solution on that? It's pretty hard. And then I thought, okay, maybe data loss prevention products will help here, because I really don't care if someone infects the point of sale. I care if someone exfiltrates the data. Well, it's pretty easy. If I have a memory scraper malware, probably I'll encrypt the credit cards so that I'll be the only one who's able to decrypt them. So if I encrypt it, how can the data loss prevention decrypt it? It can be done. But the last product is a product that's widely used on point of sales. A lot of companies just decide to put a whitelisting product on the point of sales. Well, a whitelisting product allows only specific files to run on the operating system. That's great, especially when using MD5. Because MD5, probably most of you already know that, but it's vulnerable for collisions. And then when someone decides to use a little bit hot, well, let's say SHA-256, it becomes problematic in terms of performance. So no one really can add this way of work. So I just thought about the correct solution, because there are any other incorrect solutions, and I just thought it's a long list. I just want to put this on a side and tell you what do I think that can work for point of sales. So the first approach is not technical at all. We just need to look for a little bit of intelligence before someone attacks us. So I just got few screenshots that really can explain why I think that it's good. So the first screenshot is something that I've got from the forums. And I saw that someone just looks for info about how can I access the point of sale in the US, and what is the best malware that I should use in order to get the data from it. So that's pretty easy. Someone recommends on BlackPaws, on Alina, and then someone just gives the whole information, because it's pretty easy. In a moment you can get the data. So you need to infect the firmware of the terminal. You can do this, that, get track 1, 2 data, and you have also another extended information that tells you, okay, from this specific point of sale terminal, maybe you won't be able to get the pins. So that's enough information for the one that wants to hack. Another scenario is selling a malicious firmware for Verifone's point of sale. So they say that it leaks dumps through GPRS, which is pretty nice because no firewalls and no next firewalls. So this is pretty nice just for $700. Probably you'll get return of investment pretty fast on that. Next thing is kind of an offer. No one wants to sell this because it's too cheap to sell in $700 the point of sale. So the business offer here is the revenue sharing. Okay, the last one is kind of requesting for information. So here someone just tells, hey guys, I just can't find specific data that I want to find, just looking for the pins and can't get them. So this is a pin pad that you really can't get the pin from there. But hey, hackers have a lot of creativity. So they said, okay, go to the thermal imager. The thermal imager can see where do you actually press when you pay with the pin pad, and then you'll get the number. So this is just one option that can work. Other option, if it's only limited to the specific point of sale and specific application, I believe that Sandbox can work. And I know that Sandbox, this is something that bypasses a lot of times. But again, if this is something specific and not a browser, this is something that runs only the point of sale, it may work. Till now, it works. The next thing that you should know about point of sales is that point of sales are pretty static, except the fact that patches are installed on the point of sale, nothing else changes. So that means that if we can build a profile for the whole point of sale system, or actually whole systems, then probably we'll be able to find anomaly behavior and then get the information about the one that is already infected. The problem is that if we just deploy it after infection, then everyone is normal. Okay. Next thing is kind of operating system anomaly detection. This is all those 0 days products. The nice thing here that since point of sale works with a lot of drivers, native drivers, we can actually inject a new one drivers as part of these products, and then it will be much easier to understand if someone tries to, just an example, change the driver of the pin pad and then get the numbers back. So that's pretty nice approach. But all of these probably these are products that you already heard about. So there is something that probably most of you didn't hear about. I met with one startup company, pretty cool. They say that they do runtime obfuscation. If I'll translate it into my words, they do an operating system obfuscation. And that means that they can change all the Windows system calls. They can change the names of all of them. So for instance, if we have a malware, this malware probably will try to open a socket or try to open HTTP connection. Great. The name is incorrect, so the malware won't be able to work. And this obfuscation works specifically per each operating system. So that means that if one operating system is infected and they found the naming convention, probably it won't work on other point of sales, which is pretty cool. But yet, not 100%. We have products. That's nice. But it's not all, because sometimes we'll need to add a little bit of security architecture to the point of sale, and most of it is IT problems. So the first of them is Windows hardening, which is a pretty common thing that should be done. It's not done, by the way, on most of retailers, at least the mid-size. It doesn't work. Obviously, the ones that are enterprise level, they have certain hardening. The next thing is, well, actually part of the hardening. Let's say logs, audit trail. Really? Pentium 4, guys. No one can enable just auditing there. It won't work. When you go to the store and you have an item, you just want to hear the beep pretty fast, right? You go, you just pass your code, yeah, and you hear beep. You don't want to pass the code and then wait a few seconds and then beep. It won't work, okay? Next thing is assembly signing. This is pretty common for enterprise software. Probably it can work for point of sales, and I know that it can be also bypassed, but yet this is another layer of security. Next thing is, well, the fact that we have point of sales that are deployed as thick point of sales. So we have the whole business logic on the point of sale. So probably we'll need to obfuscate the code in order to, well, let the hackers work a little bit harder. It doesn't mean that they won't bypass it. Another thing that I thought about, it's pretty simple solution. If we'll just try to isolate the process with a few users, let's say we have a simple user and another user, and if the process, the point of sale, runs with the other user, the logged in user won't be able to read the process memory of the other user. And for that, again, I have a demo. So I'm just closed here everything and remove the log. Let me just run this point of sale with another user. I have another user named Bar, also a weak user. If we look at the process monitor, we'll be able to see that we have memory scraping pause that runs as a bar and not as a foo. And now let's try to inject it. Nothing. It won't work. Well, this is a simple injection. Probably if you'll try to do it a little bit harder, you may succeed, but the original way that the operating system works It just does not allow any reading of process memory if it runs with another user. So generally, these are the solutions. So what's coming next? I don't know. I have a few ideas. Let's say that you need to steal point of sale. Who, well, raise your hand if you'd steal the point of sale, the right one. No one steals the right one? Okay, not too much. Who wants to steal the left one? Everybody, right? That's what I would do. Okay. So probably if we'll be able to steal the mobile point of sales, probably we'll see the business logic on the mobile point of sales. Well, that's nice because we can just steal it and bring it back when we want. Next thing, which is pretty challenging, is memory scraping for the mobile point of sales. Well, I suppose that we'll be able to see another skimming devices attached to the point of sales, or maybe exploiting other ways to read the process memory. I know this is pretty hard on iOS, but for Android I see that it's maybe possible. Next thing is taking the assumption that cashier is actually a hacker, because I already saw a post of a cashier that just publishes something that says, okay guys, I can give you a VNC access to my point of sale, just pay me. Okay. So maybe probably someone got it. Next thing is the rubber ducky. I suppose that even if point of sales will stop all the USB storage communications, still this USB rubber ducky can do a lot of nice things on a point of sale. I still didn't see it, but I believe that it will be pretty easy to do it. So as a summary, so everything we discussed in this session. So we have security through obscurity. The retailers believe that the fact that we don't know about retail, probably we won't be able to hack it. That's a lie. Now they know that we know. It's simple to exploit these systems. And again, this is as a result of the assumptions that we currently got in this session. And it's really hard to protect the point of sales because, as you probably understand, there is no one solution. We need to take a little bit of security architecture, maybe we need to take a few products and then combine everything together to get a not bulletproof solution yet. But as for you guys, because you're not the business, you're just the ones that buy on the point of sales, don't worry. You have insurance on your credit cards, so that's fine. Thank you, and if you have any questions, that's the time. That's the mic?
The memory scraping that you showed up there was just the PAN. But with POS systems, do most of the retail systems store PANs, or do they store track 1, track 2?
So you're asking if they store PANs?
Yeah, when it's a pin pad based POS system and someone swipes in, does the software translate it to a PAN, or does it leave it as track 1 and track 2?
Well, it depends on implementation, because pin pads can well, you have the driver. You can set whatever you want there. So you can just set the settings for the pin pad to not encrypt anything and just pass you all the data. Although, if you have direct connection from the pin pad to the issuer, probably you won't see it on the point of sale anyway.
Okay.
Okay?
Thank you.
Sure.
For all these attacks out here, why no mention of point-to-point encryption, or the encrypting the PAN at the card swipe and leaving the operating system and the point of sale out of the equation entirely?
Well, this is correct. I didn't mention endpoint encryption, and I suppose that you meant the point-to-point encryption of the
Yes,
pin pad?
P2P and tokenization.
Yeah, P2P. So P2P is something that is specific for the pin pads and not for the payment application, so therefore it's not in the scope, but yes, this is correct. Point-to-point encryption on pin pads can actually work, and again, it's not point of sale.
All right, thank you.
I'm very sad at your evaluation of the POS systems. It doesn't seem like we have much as a consumer. What can be done retroactively? There are literally millions of systems out there. Target, for example. What can Target do? What can Macy's do to protect themselves now as opposed to something in the future?
Well, let me understand if I understand it correctly. You ask how can they be
What can be applied to the existing systems now to protect them?
Well, today, the way to protect point-of-sale systems is just using whitelisting. But following a few breaches that you probably saw over the internet, they just looking for new approaches to protect the point of sale. So it starts with the vendor security, and then it goes to the operating system security. So they try to get the layered approach this case, but yet there's no standardized solution following the hype of the breaches that you heard.
Thank you.
So you say point-to-point encryption doesn't involve the point of sale, but that's sort of the point, isn't it? If you have point-to-point encryption from the pin pad all the way through the payment application to the processor, even the payment application at that point doesn't have it.
Exactly.
So why is that not covered?
Well, retailers, that's a good question, by the way. Retailers, why shouldn't they just use point-to-point encryption? Well, it costs a lot of money. Because assume that you have thousands of point of sales and pin pads. And your pin pads does not support point-to-point encryption because you need the hardware encryption in this case. So you have point-to-point encryption on hardware, and it will cost you few hundred millions, or you have the software solutions. What would you choose?
Well, yeah, Target cost, or they figure it cost them about $148 million to deal with all the fallout. I think they probably could afford a few pin pads that handle point-to-point encryption.
You're talking about retailers actually thinking next.
Yeah.
This might be kind of a naive question, but could you help me understand how chip and pin, if it does show up, might change the ballgame?
So chip and pin, it doesn't really help. Just that means that you just use pin pads to verify the chip in order to prevent fraud. But it doesn't mean that you can steal the credit cards. And again, that's only an issue of the driver that accessing to the point of sale, to the pin pad. Sorry.
I think the assumptions that you went with in the beginning are pretty crazy because, you know, I've personally exfiltrated tons of credit card information from Aloha and NCR terminals, and in no situation were any of those assumptions generally true. With small merchants especially, you know, they don't have IT shops, they don't have people who are in the know. What is NCR specifically doing to improve that, to force, I mean, listen, you know, they're retailers, they don't do the right stuff, we all know that. But we have to meet them halfway, right? So what can you guys do at NCR, or what are you doing currently at NCR to kind of bridge that gap? And thank you. Okay, so as an NCR, as I said, there's a lot of products that probably need to engage together in order to protect the point of sale. So if it's not a point-to-point encryption solution, then we're just looking for business partners and then recommending to our customers to use the specific products in order to protect their environment. Because, hey, we can't protect everything. We can just protect our scope of the product, of the vendor. Okay?
Thank you.
Can I, before you
okay. So all this is really good. I wanted to talk about one of the hacks I found for payment systems. You're talking about, sorry, my voice is kind of lost, but you're talking about payment applications. And over the last year, I did a lot of payment testing against these APIs. And one thing I found out that was the easiest to hack was if you could get on the same network segment or host, as you mentioned, of the point of sale system, you could actually just forge the HTTP request or response to trick the point of sale system into believing a purchase was successful, even if the card or payment never went through. So what I did at some retailers that hired me was I basically tricked the point of sale system into printing out receipts saying I paid cash for whatever merchandise. And I would go just grab the merchandise off the shelf and take the receipt to another cashier and say, hey, I want to get my money back. I don't want it, whatever, right? Then I get the cash and in the logs on the point of sale system.
Not that you actually did this, right?
Well, no, I was hired to do it, so it was, it was all legal. But it was interesting because on the point of sale system, everything checks out, all the logs look normal, the sale looks normal, because the cashiers aren't trained to know. I mean, they just say, oh, the point of sale says the purchase was successful. Here's a receipt, give them the merchandise. But I was basically tricking the point of sale into making it think that the server said everything was all good. And anyways, I thought it was just an interesting different angle than like anything you talked about here, but it's something that made me think about is really securing the payment application, the API, in addition to the point of sale system itself, the network segment and all those other things you talked about. But that, just want to share that.
Thanks for sharing. Thank you, guys.